So, so there is some cut, like, sorry, as if, my goodness, a lot of disturbance there. Sir. So is this the first time you're experiencing it or something, Sarthak? Or it's from your mic for sure, because when you get muted. Let me mute myself. Sarthak, could you speak? I will mute myself.
Yes, sir. I think it's problem with my mic.
So the computer microphone directly rather than if you're using an auxiliary device. Can you just do it?
All right, sir. Is it better now, sir? Hello.
So what I think you should do is please share and start speaking.
Okay.
So I probably will have to give you the sharing privilege. I'll do that. Now also is there anyway.
Hello. Can you see my screen?
Not yet.
Is it visible now?
No. Try unsharing and sharing. Time is anyways getting wasted. So let's do it quickly. Yeah, at least the sound is better. There is not much disturbance as of now. Yes, the screen is visible. Now you can show the tute.
Is my screen visible also?
Yeah.
Okay, so please read the first question.
So
And
just
try.
so just a second. I'll just give a speak for a minute. So all of these questions have been uploaded.
Your voice is not clear.
What about me? It's not clear now.
No, sir, it is not clear.
So this tutorial sheets have been uploaded in the Moodle. So I hope I am audible now.
Yes, sir. Yes.
So the tutorial sheets have been uploaded in the Moodle. So please download it and take a look at it. So the way we would do is Sarthak would present a question and we'll give you a couple of minutes maybe. So this is a short tute and it's more of an introductory in nature, just for a warm-up kind of a problem. So we'll give you some time for you to try out yourself. Then afterwards, he will also show us, explain us with the solution, and we'll have a discussion around it. That's the way we are going to do. So since being it's a remote way of doing, so it's your cooperation is highly solicited, in the sense that when we are saying please try it from your end, please do it from your So please try yourself, and if you have any queries, speak to us. Otherwise, like generally, it's like unlike an in-person tute, it's not going to be effective. So please solve the problems from your side, and if you have some issues, let's speak to us. And after Sarthak present the questions, so we'll have some 5 minutes or so time for 5 or 6 minutes for you to try out yourself. At least I think about what's the way or you can solve it. Then we'll explain you. But this is of course an introductory to not much. It's more of thought, more qualitative in nature. But when we do the subsequent tools, like, this is the way we are going to do it. Okay, Sarthak, over to you.
Hello. So I'll just explain the question. The question asks us to find the controlled variables, manipulated variables, and disturbance variables in a home heating system. And the home heating system consists of a natural gas fired furnace and a thermostat. So first you need to draw the diagram and then try to find the variables. Please try it.
Any queries? Hope you are all kind of understood.
Hello, sir.
Yeah, go ahead.
Sir, I have some problem in understanding the difference between controlled variable and manipulated variables.
That's okay. That we will take up. Control variable is something that you will control. Manipulated variable is something that you use to control the controlled variable.
Sir, but aren't they essentially the same?
So how can it be? So let's say if you're trying to change the temperature of a reactor by putting a coolant, then the coolant would be the manipulated variable. The reactor temperature would be the controlled variable. Got it?
Yes, sir.
So it can be same, but it need not be same. If you are saying using the same variable to do a feedback, as you see in the figure 2, this may be same, but again, it could be different as well. Most likely, this will be different in the industry. Okay. Who was asking that?
Sir, I was asking that when I.
Okay. Okay. No issues. So yeah. So this is the way. So please spend some time and try to create a cartoon for the figure 1. So 120, Sarthak, you can start explaining the solution. Maybe 119 or 120. Okay.
Okay, sir.
Sarthak, maybe. Go ahead.
So I will share the diagram of the problem.
So before we start, like any technically, is there any? Do you have any issues in understanding the question that you can speak of first? Otherwise, Sarthak will explain. Sarthak, over to you.
So this is the diagram of the question. I hope this is clear. So as you can see, the control variable will be the temperature of the home, the interior temperature of the home, and the manipulated variable will be a Q, that is the heat from the furnace, and the disturbance variable will be QL, that is the heat loss to the surroundings. There can be other possible sources of disturbance too, such as the outside door that is opening and closing, a loss of gas pressure, and a change in outside temperature, or the outside wind velocity, which changes the external heat transfer coefficient, and it could be windows that opens, and it can also be number of people that are inside the room, uh, each one generating and transmitting energy into the surrounding air, which will uh, uh, that can change the temperature of the home. And there can be some electric lights and appliances of any nature that are being used inside. uh, is it clear?
Any questions?
Sir, could you explain the role of thermostat in this?
So, Sarthak, I'll take that up. See, you consider any cooling system that you have in your home, for instance, AC, except the inverter ACs. So most of the time, you see that the operation of the unit would cut off when the temperature goes below your desired temperature, or it would start if it goes above a desired temperature. So most of the time the heating unit, so any heating unit, this is of course a heating unit, I'm talking about AC, which is a cooling unit. Consider your heater, like water heater that is also installed in your home. It would just work like this. It would, if the water is sufficiently hot, the power would be cut off. So the thermostat is a mechanism to make sure that this automatic cutoff happens. So it would happen is if the temperature goes above or below, depends upon the application. Okay, if it's a possibly if it's a heater, it can be temperature above and the same way. Okay, so the circuit would be broken and further heating or cooling would not be there. Is that clear?
Yes, sir.
Further questions?
So please read the second question and try to answer it. In this question, you just need to indicate whether the following systems are a feedback control system or a feed forward control system. Please try it.
So just to add Sarthak's thing, this is seemingly, yeah, so you can just keep that page, Sarthak. It's a seemingly simple problem, but it's not. This is really test you what is that your understanding what is feed forward and what is feedback. Okay, so based on the understanding, you try to figure out which one is feed forward and which one is feedback. As you don't expect your answer, so okay, some of you I am sure that you will be able to answer it correctly, but the obvious thing that comes into your mind is not the answer to this question. Okay, just think and try to answer. Maybe 125 or 126 Sarthak can start explaining the solution. So meanwhile, the general a general comment to all of you is that, of course, if you have any doubt, we have a reserved slot for doubt clearing, that is true. But if you have anything that you need to get clarified, do right away. Don't think of anything. If something is not clear to you, please ask directly. So that would help you to clear your understanding. Okay.
So both the flow control loops are feed backward control systems because the control variable, that is the flow, is measured and the controller responds to that measurement.
Sir,
Is that
what is
clear?
FC in the diagram?
It's a flow controller.
So, so just to add, right? So this is a very, what I would say, as I told, this is a tricky question to answer. So look at the definition of the feed-forward control loop. So the feed-forward control loop, what it does is measure something from the inlet. Okay, and it most likely it would measure a disturbance, something, and it would try to correct your output. But here you see that your measurement and the control variables are both of the same. It is just a matter where you place the sensor. You measure the flow, okay, and correct the flow. One is, so it's just a matter where did you keep your sensor. So, but feed forward control system is fundamentally measuring a different variable and try to control the flow of liquid in the sense. So here it's just measuring the flow, be it feed forward or feedback, just measure the flow and try to adjust the flow. So information wise, what you call the architecture wise, both are doing a feedback control. FC just means flow controller. But let's say if you have a third different variable that you measure somewhere in the upstream, okay, that could be like a disturbance in the flow by means of some anemometer or something, then you try to control your flow, then it would have been a feed forward control. So here technically it is just a difference in terms of placing the sensors left or right, but eventually both are doing a feedback correction. So you measure the flow and control the flow. So you are not anticipate there. So see, as I told in the definition of the feed forward control, there should be an anticipatory action. So based, you measure something and it would, you can think of the example that we have presented in the note. You measure the concentration of x1 a component in the input and try to control and assume that that would have an effect on the output, then you control something else. So here nothing is happening, so you are just measuring the same thing and controlling the same thing. So that anticipatory action is not being there. So both of them are technically feedback controllers. It is only the placement of sensors. One is just placed in the first case you place the sensor just before the control valve. The second case you just place the sensor just after the control valve. If you have any issues or any confusion, let's discuss that. So the
Sir, will the feed transmitter tell us the value of the properties about the flow?
No, you see, FT is flow transmitter. No, it is not feed transmitter. Of course, it is the same thing, right? So you got it. No, if you are
Sir,
looking
but you said
at
that
something,
we will first get
let's
to
say
know
if you are
about.
trying to measure a third variable, and if it makes an anticipatory, yeah, go ahead.
Sir, as you said earlier that we would have to know about the properties or information about the flow, and then we can go on and manipulate the variable using the flow control. But I cannot see from where we will get the information about the flow here.
No, I did not understand your question. Can you speak? Can you be a little more clear?
Sir, you said that in the feed forward control system, we first need to know the information about the value of flow. So
no, I'm saying some other variable that control the whole process. So let me just give me a minute. Let me try to share the notes to you. Sarthak, please unshare for a minute.
Yes, sir, I have.
So look at this case. So I hope my screen is visible to you. Okay. Fine. Hello.
Yes.
yes, sir.
So here, if you look at how the feed forward way it works, it measures the composition of X1 and anticipated what would have happened. Okay, if there is a change in X1 to X, then it does a control action to correct the X by changing X2. So there should be an implicit relation that brings in that should give us a change that should relate us a change in input to change in output, or there should be a relation that gives us a input to output. So here the input here, whatever is the change, is a totally different variable that you are planning to control. Got it? No? And you are anticipating if there is a change in X1. Okay, then what would have been the output? Then you go back and correct the same thing. While while in your question, what is happening? Give me a minute. So there is no anticipatory action. You measure the sensor and correct the same thing. You got it. So feed forward controller should have some anticipatory action. So here there is nothing happening. You measure FT means flow transmitter, FC means flow controller. You measure the flow and correct the flow. You measure the flow and correct the flow. So it is just merely placing the sensor left to the controller and right to the controller. That is only thing that is happening. Eventually you are measuring a variable and trying to control the same thing. There is no what I would say anticipatory action in place. Is that clarifies?
Yes, sir.
Okay, so I will. Any other questions on this?
Sir, what could have been in the question so that it would have become feed backward system? What
No, it is
changes could have been made?
Both are feedback. If let's say if you need to have a feed forward, okay, fine.
Yes, sir.
Okay, so let's say then what you should do is you may measure something else. Okay, you would, so you eventually you wanted to measure the flow. Okay, so let's say now you measure a pressure here, and you anticipate what would have been happened if there is a change of pressure. Then you compute the flow, then you correct it. That would have been a feed forward controller. One example of a feed forward controller. Got it?
Okay, sir. Yes, sir.
So just think this. So placing the sensor left and right will not qualify a control system as a feed forward feedback. In feed forward, you need to measure a third variable, and that variable should give you an anticipatory action. And that basically something has to be predicted, and based on the prediction you correct something, as we have seen over here. Give me a minute. So here when you use a feed forward control, what it would do is, just a second. Okay. You measure a third variable here. So you wanted to control what x, but you measure the composition at the input, then computed what would have been a potential effect on that over here, then control your x1. Sorry, x2. You measure x1, and based on some relation, you are figuring out what would have been the effect of x1 on x, and use that information to control x2. So that is not happening here, but what you are simply merely doing is measuring the same variable and controlling the same variable. So it's just a sensor placement problem. You can just keep it over here or just keep it over here. Okay. I hope this is clear. I hope this understanding you should have. Is that fine? Yeah.
So what is, so I have this question, what is the significance of that last line, that the distance between the FT and FC is less?
Okay, so this is also just to make sure that this sensor is placed just close to the what I would say the control valve, so that you're basically measuring FT that flow left to the control valve and right to the control valve may not have a big difference. Got it? Hello.
Yes. Yes, sir.
Ayushi. So it just tries to say that, say, let's say this flow transmitter is placed 2 kilometer upstream, then it may be still a feed forward control. You got it, no? Technically not, but I could say that it is measuring 2 kilometer upstream, means that you are measuring much ahead. But now what is happening is it's just merely a sensor placement problem. Sometimes there may not be enough space to keep the sensor in the line, so somebody might have just kept it left of the control valve or right of the control valve according to the design convenience. So this particular sentences reinforces that it is just a sensor placement problem. I hope you understood this.
Yes, sir, it's clear. Yes.
Okay, so then let me unshare. Any questions further? Okay, Sarthak, please go ahead. I have unshared.
Please read the third question and try to solve it. In this question, you need to identify manipulated variable, control variable, uh, and name an important disturbance and tell the feature and tell us how the valve is involved in a control system and what does it manipulate. So the manipulated variable will be the flow of heat energy, and the control variable would obviously be the room temperature, and a valve is used and it is used to manipulate the flow of heat energy inside, and disturbance variable would be the outside temperature, upstream pressure of the heat energy, and it also changes with respect to time as it is asked in the question. Is it clear?
So can you disturbances?
Sorry, I didn't get you. Can you repeat, please?
What is the answer of fourth part? Important disturbances.
Okay, so the outside temperature and upstream pressure of heat energy.
So you can show that figure, maybe.
Yes, sir.
So see, these are slightly open-ended questions. So who asked that question, Keshav?
Yes, sir.
So these are, like as I told, the slightly qualitative and open-ended questions. So you can, if you can substantiate your answer, that should be fine. At the moment, if you look at this particular diagram, whatever Sarthak told would be, they are, I would like to call them as candidate solutions. So if you
And sir, like you mentioned heat energy in both manipulated and disturbance variables. So, like, is it possible to have it in both?
Sarthak, yeah, go ahead. What was the question? So
I didn't
hello.
get the question. Can you please repeat? Who was it?
I am asking, like you mentioned heat energy in manipulated variable as well as in disturbance variable. So, like it can be both at the same time in the same apparatus.
I said the manipulated variable will be the flow of heat energy, and disturbance variable will be the upstream pressure of the heat energy.
Okay,
No,
sir.
so it's like this. Let me just make it clear. Okay, so basically, what is happening? It's a fuel gas burner. You are burning a fuel to get the what I would say, to get the heat, desired heat in the room. Correct. So how do you generally control at room temperature? If you need to increase the heat, the temperature, you will have to increase the supply of heat. Correct. So how are you getting this heat? How so heat is not a what you call true variable. No, it is a latent variable. In the sense that you, unlike the temperature or pressure, heat is not a true variable. You cannot measure heat directly. You will have to only measure something else and do something. So increase in heat or decrease in heat is basically helping you to increase or decrease the room temperature. So absolutely they are manipulated variable, because that is one thing that you manipulate. But again, so the question is, how do you manipulate the different thing? Technically, the increase or decrease or heat would give you the result of increase or decrease of temperature. Okay, so now coming to the pressure. So what he told, I think just to be precise. So I assume Sarthak intend to say the pressure of the fuel gas. See, you are buying the fuel gas from, let's say, be it in Delhi or somewhere. Let's say it is coming via pipe. Pipe, we call it as PNG, right? Pipe natural gas and things like that. So who supplies here in Delhi? It is Indraprastha Gas Limited. So let's say some of the upstream lines got chopped or there is some problem, and that pressure of the fuel gas that is coming to the burner, which you need to burn it, right? There is some disturbance due to some upstream problem. So then that become a disturbance. Hope you know, I try to make it a bit more clearer. Hope this makes more sense.
Yes.
Got it? Yeah. Further questions? Any more questions here?
Sir, like you said, manipulated variable is the amount of heat that is flowing. But sir, like the amount of heat that flows depends on the flow rate of the fuel, no, sir. Like, can we say the flow rate of the fuel as manipulated variable?
More accurate way of saying. So as I told, what I would say, heat is a latent variable. You as rightly pointed out, you cannot measure heat as a true variable. So you can, if you want to if you want to make one step down, you can say that the flow rate of the fuel can be the manipulated variable, which eventually result in the manipulation of the heat, which eventually result in the change of the temperature. There is no harm in saying that. As I told, these are qualitative statements. Got it? If you need to have a more tangible variable, then it's flow rate, yes. But what is really happening is the change in heat is that being converted into the increase or decrease in temperature. So there is no harm in saying that heat is a manipulated variable, but heat manipulation of the heat is done through the change of flow rate. Okay? Perfect. Any further questions?
So read the fourth question. It needs you to find the control variable, manipulated and disturbance variables uh, of the given figure. And it's a homework question, so please try it out before your next tute. And we shall proceed to the fifth question. So
Karthik, you can briefly introduce the problem. That would be helpful rather than they can read it. Of course, you can just briefly summarize what is that is expected.
So the fourth question or the fifth?
Fifth one. Fourth is anyway homework.
Yes. So in the diagram, it's a distillation column, and B, D, R, and F, they represent the molar flow rates. And what you need to do is you need to control the distillate composition, that is Y, uh, with the disturbance in the flow rate F. So you need to uh, you need kind of measure the flow rate F and change the variable Y. So for this, you need to propose a feedback control system and a feed forward control system. And you cannot manipulate F. It can be only it can only be measured. You cannot manipulate F. So I will share the the sketch. So this is the feed backward control system. You are just measuring. You're not measuring any third variable. You're just measuring it and changing it to the control valve. Uh, in case of feed backward, where AT and AC is analyzer, transmitter, and composition controller. And in case of feed forward control system, you are measuring F and then you are changing the flow of D. So FT and FC are flow transmitter and controller. So this is the difference between feed forward and feed backward. That in this you are measuring a third variable, that is F, and then changing your what you need to change. Is it clear?
Thank you, sir. Just to add, see, just not measuring the third variable. The third variable, sometimes you measure, you can keep that figure. Yeah. So just not making, so see, the fundamental difference between the feed forward and feedback control system is that, so there is some level of anticipation. So you are measuring a variable that is in the feed line and trying to correct something in the output. So the level of anticipation is that, okay, what would have been the effect of the feed in the output, and you would go and do the change. While go back to the feedback. So feedback, what are you doing? You are trying to measure. So here also you see your measurement variable is a composition, but you are controlling the flow. So you are controlling a third variable and measuring something else. But the point is that there is no anticipatory action. You are not only looking at the feed and what is happening at the output, and you are not going to go and change and control, but you measured your distillate composition and basically you adjusted the distillate flow rate. While in the previous case, you were measuring the feed composition, if I recall. The feed composition, we thought, okay, this is the feed. If the feed is bad, your product could be bad. Feed is good, the product could be good. So based on the feed condition, you went ahead and changed the distillate composition or distillate flow rate. So is that making sense to all of you? Any questions here? So this should reinforce your understanding regarding feed forward and feedback. Okay. Any questions?
Yes, sir. Hello.
Go ahead.
So can we say that it's a generic way that in feedback we place sensors at outlet, and based on what the sensor senses out, we manipulate.
So see, I would say that, so yeah, outlet in this. Okay, go ahead. So see, there is no anticipatory action. You are. So see, so when you try to make general statement, most likely this may be true, but I don't know whether I can put you a counter example. So here you are interested to control the distillate. So you measure the distillate composition and try to control. So in that way, your sentence, whatever your argument seems to be correct, but I am not sure I can put a counter example to show that. Got it, no? Who's, who was asking that question? Shruti?
So could you please repeat? Like I lost in between.
Okay. So see, our variable of interest was distillate. So you measured distillate, correct? Then you control a variable that could have an impact on the distillate. Here it was distillate flow rate, but you measured not the flow rate, you measured the composition of the distillate. Is that clear to you?
Yes, sir.
while in the feed forward, you measured a variable in the upstream. So not in the downstream, you measured something in the upstream and you anticipated there is some problem might happen in the downstream and you did a correction. Correct?
Yes, sir.
So oftentimes, I would tend to agree with your argument. The variable that you need to measure, or its what you call its related variable, would be measured in the feedback control, while in the feed forward you measure some variable in the upstream, and you would tend to anticipate what would have happened if they kind of enter into the system and start taking the corrective action from that point onward. Okay.
Okay, sir.
Any further questions?
Hello, sir.
Yes.
Yes, so I was wondering, is the control valve here capable of manipulating the composition as well? It can.
No.
So
Control
shouldn't it
valve,
be
what it will
placed?
do?
It
Go
would
ahead.
manipulate the flow, right?
Yes. Control valve will only manipulate the flow. What
So
is the
shouldn't
question
it be
now?
placed differently, as the question dictates that we have to make sure that the composition Y does not change? But if we place the control valve here, we would only be able to manipulate the flow D, and the Y
Okay, so
would
I'll tell you
would
something. So see, now
right.
tell me, what is your proposal? What if
Um,
you were, what would you do?
right. So the point I'm trying to make is that I understand the feedback and feed forward system here, and if we were to place the control valve somewhere where the column is getting the input, the B side, right? So maybe we
B.
could. So B is the B and X here, the
So that is
stream.
like, so that's fine. Yes.
Right. So that way we may be able to control the Y, the final composition Y of the output stream.
Okay, so you are trying to say that, okay, instead of so go to the next figure. So yeah. Okay, so your point is, instead of controlling the distillate flow, but you should understand the distillate flow. If you change, so see, if you put the lesser distillate flow output, the again the product would be sent as reflex, and it would try to improve the purity. That argument you got it right.
Yes.
So even if you place here or place here, so let's say you are trying to say that instead of controlling the distillate flow, I will go and change the steam flow to increase the heating. That's your argument, right? Kind
Yeah,
of.
sir. As we were at the example that we covered in the class, in the feedback model itself, we measure the X at the output, then we change the X2, so that we'll get the required X. Am I making
Yes.
sense
So
there?
I no. So I'm no. I'll tell you. So this is one
Yes.
possible way to implement a feedback
Right,
control.
right,
You
right,
are
right.
the distillate. So if you really would like to change the outlet composition, measure the outlet composition, and you are, instead of changing the distillate flow rate, let's say you are changing the what you call uh, this is reboiler flow rate. This is reboiler duty, na? So you're
Okay.
extracting you're extracting the feed and increasing the heat and send it back. You can also change the control over here. That should also be fine.
Right.
Got it. Uh, is this clear to you?
Yes, sir. Yes. Thank
This
you.
is another architecture of feedback control. There is no harm in doing.
Right. Thank you.
Any questions? We are back to PM. If there are any questions, we'll take up. Otherwise, we will close the session. Any questions? Let me ask once more. Okay, if there are no more questions, I would thank Sarthak and Niket for conducting the TUT and also all participants for attending it. Okay, see you in the next class. And if you have any issues, we shall take it up at either in the class or during the doubt clearing session or even the next tute. Okay, bye bye.
Okay, thank you, sir.
Sure, sir. Thank you.
Okay, thank you, sir.
Thank you.